So each side opposite to a small, yeah. So considering this first triangle, this one, I'm going to use to label with a green color, right? So this is side B, this is side D, and this is side A, right? And then considering the other triangle, I'm going to use a purple color. This is side D, this is side C, and this is side B. So for us to find AD, we ask ourselves which one is more ideal to use, the sine rule or the cosine rule. You realize the sine rule, one of the ratios must be complete, okay? So since we are looking for the side and we're given the angle opposite to that side, we're going to apply the cosine rule, all right? So this is how we work it out. So we're using b squared equals a squared plus d squared minus 2ad cos b. So make sure that you are flexible. That's normally the general formula uses ABC, but sometimes a triangle might have any other variables around. So we have our b squared being equal to a is 12.1 squared plus d, that's 9.6 squared, minus 2 times, that's 12.1 times 9.6, and then this is cos 56 degrees. Cos 56 degrees there. Then what we can simply do is to punch in all this into your calculator and see what value you get here. So we have b squared being equal to, right, that's 12.1 squared plus 9.6 squared minus 2 open bracket 12.1 close bracket and then 9.6 close bracket cos 56 equals, I'm getting 108.658347. Then I'm going to say square root of the answer, right, because we need to insert a square root this side and a square root on the other side. So that means my b is equal to 10.42392, which is approximately equal to 10.423 significant figures. So that means our AD value is 10.4 centimeters. 10.4 centimeters. Now the question wants us to find the obtuse angle BDC. Which one is BDC? The obtuse angle BDC. Right, this is what we're looking for. B starts from here, D, C, that's one. This is the angle that we're looking for. Right. Now let's look at the number of marks. That's 4 marks, BDC. And the question said obtuse. So we need to be extra careful there. Are we using the sine rule or the cosine rule? So we can go back to the diagram. Right, we're looking for an angle. We can say this is theta, right? This is theta in here. Do we have one of all the sides? No. Yeah, we have side D. Then yeah, we can use the sine rule. Okay, we can use the sine rule. So we are going to say, right, sine D, which is the angle BDC, right? Sine D over D is equal to, right, sine D over D equals, right, sine C over C. I'm using the purple marks, sine C over C. And of course this is also equal to, you can take the other set, right, which is sine B over B, sine B over B. But now you realize this ratio, we're not going to use it, so we're just focusing on these two. So from here we have sine d over the side d is actually 15.8 centimeters. That is 15.8. This is equal to sine c. The angle we're given is 47. The side is 12.1. So that's sine 47 over 12.1. Now from here I'm going to divide this part. So that means sine d, you multiply both sides by 15.8. 15.8 sine 47 degrees over 12.1. Right, and then we're going to find our answer, get our answer. That's fraction there, 15.8 sine 47 all over 12.1. Right, we're getting 0.95499. This is sine d, which means d is equal to arc sine of 0.95499. So I'm saying arc sine of the answer, right, I'm getting 72.74 degrees, which is 72.7 degrees. Now the question is said the obtuse angle. You realize this is an acute angle, so now therefore obtuse of that angle is equal to 180 minus 72.7. This gives us what? Right, 107.3 degrees. Remember, when you're giving out your answers in angles, you leave them to correct to 1 degree, 0.1 degree. Right, now let's move on to the next one. Question wants us to find the area of the quadrilateral. So for you to get the area of the quadrilateral, you're going to use the area of each triangle. So you can say area of triangle 1 equals half AB sine theta. So we're not using AB as such, but you're going to use the two sides which are forming the angle, which is 9.6 and 12.1, and then you use angle 56 degrees. Half 9.6, sorry, half of 9.6 times 12.1 sine 56. Right, this is plus area, right, let me not rush things there. Then you can also have area of triangle 2, still the same thing, half AB sine theta, half of the two sides forming the angle there. Right, we just found that this angle is 72.3, is it 72.7? Right, we just found out this angle. Right, this is 72.7. So we're going to use this angle, the theta that we have there. And wait, if we use that one, then we won't have the sides. So what we need to do is to find the other angle, right? We need to calculate this angle. So we are adding 72.7 plus 47.0, that is 7,911, that is 119.7. Then you say 180 minus 119.7. Right, 180 minus 119.7, we get 60.3. So this angle is 60.3 degrees. That's the one we are using since we have this side and that side. So this time around we're now saying, right, half, 12.1 and 15.8. Right, 12.1 and 15.8 sine 63, 60.7, 60.3 there, right? Good. 60.3. Then this is equal to, right, now let me do the calculations. I have half times 9.6 times 12.1 times sine 56. The first one I'm getting 48.150. Right, the second one I have times 12.1 there times 15.8 times sine 60.3 equals, that is 83.0. So now the total area equals 48.15 plus 83.0 plus 48.15. So we get 131 square centimeters, because this is 131.18 to 3 SF is just 131. Yeah, that's what you're supposed to do on this one. I hope we learned something here. Quite a long question with a lot of reasoning. Alright, see you next time.